Hi guys, it's Mrs. Glenn. Welcome to the 5.3 Factoring Trinomials with Leading Coefficients. Alright, so in this video, we've done factoring by grouping for 5.2 with regular polynomials that do not have leading coefficients. And now I'm going to show you how to do it when you have a leading coefficient. So what I mean by a leading coefficient is this a term right here is not just x squared, but it has a number in front of it, like this one has 3x squared. So when you have the three terms, like you do, the 3x squared minus 11x plus 10, something like that with the ax squared plus bx plus c standard form, but the a is greater than 1, you're going to use this method. All right, so let me get started. So the first step is to multiply the first term by the last term. So you have 3x squared times 10. So we take 3x squared times 10 and you get 30x squared. Then you're going to find all of the factors that multiply to 30x squared, but also add to the b term. So do you see this middle one is the b term, this negative 11x? So we have to list everything that multiplies to 30x squared first. So you're just going to make a list underneath 30x squared. So we have 3x times 10x, 5x times 6x, 2x times 15x. And then you also have to do the negatives too, because remember we have to add to be negative 11. So we're going to have to do all the combinations of multiplying to equal 30x squared. So you also have negative 3x times negative 10x, negative 5x times negative 6x, and negative 2x times negative 15x. So now we're going to add all of those pairs together to see if we get to negative 11x. So we have 3x and 10x adds to be 13x, so that doesn't work. 5x plus 6x is positive 11x, but we're looking for negative 11x, so that doesn't work. 2x plus 15x is 17x. Nope. Negative 3x minus 10x, because adding a negative is the same thing as subtracting. So negative 3x minus 10x is negative 13x. We're getting closer, but that's not it yet. And then we have negative 5x plus negative 6x, which is your negative 11x. And just to make sure, we've got negative 2x plus negative 15x would be negative 17x, so that doesn't work. So now we know our two factors, which are negative 5x minus 6x. And then we're going to rewrite the original question, and instead of writing negative 11x, we're going to put negative 5x minus 6x in its place. So we just expanded our polynomial is all we did. So we just took a negative 11x and we found the two factors that multiplied to be 30x squared and added to be negative 11x. And now because we have four terms, we can do the group and factor. So we're putting a parentheses around both sides, find the GCF of the left-hand side, GCF of the right-hand side, put the two GCFs in one parentheses, and your common binomial in the other parentheses, and that's your answer. All right, so now I'm going to show you some examples. All right, so for number 1, ay squared minus 10y minus 3. So you always want to check to see if you have a GCF between the three terms, and there are no GCFs between 8, 10, and 3. So we're going to now just do a times c, which is 8y squared times negative 3. And that turns into negative 24y squared. Now we're going to list everything that multiplies to be negative 24y squared. What I like to do is I like to start out with the small numbers, like negative 3, and think of everything that multiplies to be negative 3 times what, and that would be 8y. Then I go to 4, so that's negative 4y times 6y. Then I go to 5. 5 doesn't work, so I skip 5. Negative 6y times 4 will be negative 24y squared. And then 7, 8 we already did. 9, no. 10, no. 11, no. But 12 does. Negative 12y times 2. You also want to sometimes put in your 1 times negative 24, but not always. If you know that it has to add to be negative 10y, 1 and 24 are so far away from each other that when you add them together, it's not going to be close to 10. So in this situation, you don't need it. And then remember, we want our negatives as well. So we now have to switch the negative to the opposite term. So positive 3y, negative 8y, and so on. So now we're going to add everything together and see which one comes up with our negative 10y, which is our b term. So we have negative 3 plus 8y, which is positive 5y. That doesn't work. Negative 4y plus 6y would be a positive 2y. Nope. Negative 6y plus 4y would be a positive, or a negative 2y. That doesn't work. Negative 12y plus 2y is negative 10y. There we go. So that one's it. So now that we have those two terms, you could go through and check those, but negative 12y and 2y are the two ones that we're looking for. So we're going to change our original equation, our polynomial, from 8y squared minus 10y minus 3 to 8y squared minus 12y plus 2y minus 3. So we just expanded that negative 10y out into the two terms that we found. Now you're going to do your group and factor. So parentheses around each grouping, find the GCF of the left and the right, and put your two GCFs in one parentheses and your common binomial in the other. And those two parentheses are multiplying each other, so there's no sign in between, and that would be your final answer. All right, number 2, again, we're going to multiply a times c, which is 9m squared times negative 2. And that turns into negative 18m squared. Then you're going to list everything that multiplies to be negative 18m squared. So I start with the smallest one that I can think of, which is 2m and negative 9m. Then 3m and negative 6m. 6m and negative 3m. So now we're just doing the opposites. Instead of it being 6m that was negative, now 6m is positive, and 3m is your negative. Then 9m and negative 2m. So we switch the negative on that one as well. So that's all the combos other than 18 and 1, but we know that 18 and 1 are 17 away from each other, so it's not going to add to be 3m, so we don't need to include it again. Unless you want to. If you want to be thorough, you can do it every time. So now we're going to add those together to see which one comes up with 3m. So 2m plus negative 9m is the same as 2 minus 9, which is negative 7m. So that doesn't work. Oh, I listed my ones anyway, just to show you. So that doesn't work. 3 minus 6 would be negative 3m. We are looking for positive 3m, so that one doesn't work. 6m minus 3m would give us our positive 3m, so that one is it. And you can go through and check the other ones, but we already know those don't work. So now you're going to take and rewrite your original equation, or polynomial, 9m squared, and instead of writing 3m, we're writing 6m minus 3m, and then minus 2 is from the original problem. And now you're going to group and factor. So parentheses around, oh, and then also I want to point out, you know that it's a positive 6m, because right here, it was a positive 6m. So you know what sign to put right here. Just so you know when you're putting that in, whatever sign is from the 2 you found, that goes with, and back into your polynomial to create your new one. So now we're going to group and factor. So we put parentheses around the left and the right. Find the GCF of the left-hand side, the GCF of the right-hand side. Put your two GCFs in one parentheses and your common binomial in your other. And you have your final answer. All right, number 3, 5m squared minus 17m plus 6. Multiply 5m squared times 6, and you get 30m squared. So we're going to find everything that multiplies to be 30m squared. Another way to write when you're multiplying is two parentheses that are multiplying each other, or just two parentheses that are close together like this. So we don't have to put the little dot in between. And that helps when you're dealing with negatives, so that you can make sure your negatives are not minus signs and it gets confusing a little bit. So using parentheses makes it a little bit easier. So then I'm going to go to 2. Well, 2 times 15, and 3 is 3 and 10. There's no 4. 5 would be 5 and 6. And then we have negative 1 and negative 30, negative 2 and negative 15, negative 3 and negative 10, negative 5 and negative 6. And if you're wondering why I didn't do the opposites like 30 times 1 and 15 times 2 and 10 times 3 and 6 times 5, it's because all of those are the same exact thing. 30 plus 1 is the same as 1 plus 30. So you would just be wasting time by doing, the opposite like that. The important thing is to do the opposites with negatives, not necessarily flipping them around and doing 30 first and then 1 second. All right, so now we're going to add all the way through and see which one comes up with our negative 17m. So 1 plus 30 is 31. That doesn't work. 2 plus 15 is 17, which is close, but we're looking for negative 17. 3 plus 10 is 13. That doesn't work. 5 plus 6 is 11. Negative 1 minus 30 would be negative 31. Nope. Negative 2 minus 15 is our negative 17. So there's our 2. Negative 2 minus 15m equals negative 17m. So now we're going to rewrite it with negative 2m minus 15m in the middle. But I want you to notice something. When I'm rewriting this, I'm going to flip the negative 15m and negative 2m so that negative 15m goes first. And we talked about this in class. The reason why you want it to go first is because 5m squared right here has more in common with negative 15m than negative 2m. You can pull out a number and a variable. So if you just write it negative 2m minus 15m, you're going to have to rearrange it at the end. So just, be aware of that when you're putting them in. If you can flip them and have more in common, then do it before you get started. You don't always have to. It's just, whether or not it's going to have more in common. All right, so then you're going to group and factor. So put parentheses around the left and the right-hand side. And GCF of the left, GCF of the right. Common binomial, so put the two GCFs together. And common binomial is the other half. You can also check your work. So if we were to multiply it back again, you'd have 5m times m is your 5m squared. 5m times negative 3 is negative 15m. Negative 2 times m is negative 2m. And negative 2 times negative 3 is positive 6. And that matches the original before we did our grouping. So we know we have the right answer. And make sure you check your work. All right, number 4, a times c, so 2x squared times 3 would be 6x squared. Find everything that multiplies to be 6x squared. So we've got 1 and 6, 2 and 3, negative 1 and negative 6, and negative 2 and negative 3. And which out of those 4 choices would also add to be 5x? Well, 1x plus 6x is 7x. So that's not it. 2x plus 3x is 5x, so that must be it. So the other 2 are not it. So we're going to take 2x and 3x and put them in to replace the 5x from the original problem. So now we have 2x squared plus 2x plus 3x instead of 5x. So we just expanded that 5x out. Now I want to make sure you know that you're not just going to come up with 2 numbers that add to be 5x. It has to also multiply to be a times c. So we're not just randomly finding 2 numbers or 2 terms that add to be 5x. We actually have to find that they meet both situations, multiplying to be a times c and adding to be b. So if you just want to remember, multiply to a times c and add to b. So that that's the 2 terms you're trying to look for. All right, so we're going to group and factor, find the GCF of the left-hand side, GCF of the right-hand side. Our 2 binomials match, so we put the 2 GCFs together, the common binomial in the other parentheses, and we're good. So now you can check your work. So 2x times x is 2x squared, 2x times 1, so 2x times x, 2x times 1, 3 times x, and 3 times 1 gives us 2x squared plus 2x plus 3x plus 3, and that does match the one from up above before we group and factored. So it is the answer. So 2x plus 3 times 3x plus 1 from right here. All right, number 5. So we've got 10k squared plus 75k plus 35. So we have pretty big numbers here because when you multiply 10k squared times 35, you're going to get 350k squared. So that's a huge number to try to list all the factors for. So what I would recommend that you do is 350. If you take a 0 off of 350, it's 35. 35 is a much easier number to work with when you're listing all the factors, right? So if you think about 35, well, 7 times 5 is 35. 15 times, well, that doesn't work. Okay, so 7 times 5 would be 35, and 35 and 1. So if you listed that, but then added a 0 to one of them, so let me show you what it look like. So I'm going to list this like this. So it's another way to organize your work. You can make a T-chart. So the right-hand side is what adds to be, and the left-hand side is what multiplies to be. So instead of using 350, let's try to use 35. So we know 7 to 5 multiplied to be 35. So 70 times 5 would be 350. because you're adding your 0 back in. And if you add 70 and 5, you get 75. So see how much quicker it is to get to the answer than it is to go through 1 times 350, 2 times 175. That's going to take you forever to get all the way up, to the answers. So if I find a similar number that's close to 350 and try to work from there. I mean, you could go through and 1 times this and 2 times that. You can get it when you get to 5, but it's a lot of work when you're dealing with a big number like that. You could also flip it around and have it be 50, let me go back a little bit, 50k times 7k. Instead of putting the 0 on 70, we put the 0 on 5. So it's 50k times 7k. But when you add that together, you would get 57k. So that doesn't work because we're looking for 75. All right, so now we're going to take 70k and 5k and replace it in the original equation. So now we're going to do group and factor and find the GCF to the left, GCF to the right, see if the two binomials match, and they do. So we put the two GCFs together and the common binomial together, and you have your answer. And then you can check your work by doing 10k times k, which is 10k squared. 10k times 7 is 70k. 5 times k is 5k, and 5 times 7 is 35. Does it match the original one we started with? Yes, it does. So we know that it is the right answer. And it's very important that you check your work with these because there's a lot of steps, which means there's a lot of places where you can make one tiny mistake and then it throws your entire answer off. So it's important to check your work. All right, last one. 12x to the third plus 2x squared minus 2x. Well, I know immediately we have to pull that x out because they all have an x in common. But also, they also have a 2 in common. So you actually should be pulling out 2x, which would leave you with 6x squared plus x minus 1. So then if you do your 6x squared times negative 1 for your a times c, you can make your little t-chart here. So you have a times c, and then it adds to b. So a times c is 6x squared times negative 1, which is negative 6x squared. And it has to add to be b, and b is just x, which is 1x. So if you list everything that multiplies to be negative 6x squared, you've got negative 1x times 6x. And negative 1x plus 6x is 5x. So that doesn't work. And then you have negative 2x times positive 3x. And negative 2x plus 3x is a positive 1x. So there's our answer right there. So now I'm going to look and see if I put negative 2x first, is that the greatest factor with 6x squared? And it's not. If I put 3x with 6x squared, it will actually be a lot better. So if I put it here, so I'm going to switch our numbers around. Instead of putting negative 2x first, I'm putting 3x there so that the 3 and the 6 have the highest GCF number together. And then negative 2x would go next, and then negative 1 at the end. So now we would find the GCF of 6x squared and 3x, and the GCF of 2x minus 1. So then this is 3x, which will leave you with 2x plus 1. And then this does not have anything in common, so you're going to put a 1 out in the front. And negative 1 times positive 1 would get us back to our negative 1 right here. And then negative 1 times 2x would get us back to our negative 2x from there. So they both match, so we know we're right. So we have 3x minus 1 for our two GCFs, and 2x plus 1 for our common binomial. And let's just check our work. So 3x times 2x is 6x squared. 3x times 1 is positive 3x. Negative 1 times 2x is negative 2x. And negative 1 times positive 1 is negative 1. And does that match the one we started with up here? Yes, it does. So we know we're good. So we checked it. So then our final answer has to include that 2x from the very beginning that we pulled out and the two parentheses. So you have 3x minus 1 times 2x plus 1, just like the grid words we did in class. All right, very good. Go Seahawks. Woo!